Recently in one of my weekly live streams, which I do every Monday night at 5 o'clock Pacific time, I talked about quotient rule and I broke down the quotient rule formula to make it nice and simple. Well, I wanted to go back and show you one of the examples I did in that live stream, and so that's what this video is going to be about. Be sure to stick around at the end of the video, and by the end you'll be feeling a lot better about quotient rule and how to apply it on your own so that you can boost your scores and do well on all your exams. And just a quick reminder, quotient rule is one of the topics covered on my Calculus 1 study guide and my complete Calculus 1 package. If you want to check that out, there is links down in the description and the pinned comment below where you can learn more about both those things. They are both available for instant download, so you can start using them right away. But anyway, without further ado, let's go ahead and jump into this example and I'll show you how you can apply the quotient rule and hopefully make you an expert by the end of this video. Use the quotient rule to find the derivative of this function here, where our function is y equals x plus 1 all over x cubed plus x minus 2. So again, let's go ahead and start out with the quotient rule formula. So the derivative with respect to x of high over low, the high part of our fraction and the low part of our fraction, is low d high minus high d low all over low squared. We're going to write out the high part of our fraction, which is just the top of our fraction, x plus 1. The low part of our fraction, which is just the bottom, the low part, x cubed plus x minus 2. And then again, we write out our d high and our d low. And like I said, this is one of the topics covered on my free Calculus 1 study guide and my complete Calculus 1 package. If you want to grab those or check those out, learn more about them, whatever you want, there is a link down in the description below. Highly recommend checking those out. They are very helpful. Gotten lots of positive feedback on those and people getting some really good use out of them. So highly recommend checking those out for yourself. Then for this, we will take the derivative. The d high is just the derivative of high. So the derivative of x plus 1. The derivative of x is just 1. The derivative of a constant plus 1 is 0. So that won't do anything. Then for this, we're going to use power rule. So we bring our 3 down in front, leave our x as x, minus 1 from the power, bringing it down to 2. The derivative of x is just 1. And then the derivative of a constant minus 2 is 0. So that won't do anything. Then again, we apply this formula. So low d high, low, and again, let's go ahead and put these in parentheses. It does really help to kind of keep things straight. Just put all 4 of these. As soon as you figure out your high, low, your d high, your d low, just completely surround them with parentheses. Because now what we're going to do is we're going to do low d high. So this whole low, so x cubed plus x minus 2 in parentheses, times d high, so times 1, then minus high d low, so minus x plus 1 in parentheses, times d low, 3x squared plus 1, all over low squared, so all over this whole thing squared. And this is what y prime is going to be. Okay, so now we can go ahead and simplify this. So we will x cubed plus x minus 2 all times 1 is just the same thing, x cubed plus x minus 2. This is going to have to be FOILed. So we're going to do the first term times the first term. And this is another thing to be very careful of when it comes to distributing and all that in parentheses. We need to keep a minus sign here, and then we're going to go ahead and keep parentheses around this foiling because the negative sign is going to have to be distributed to all this stuff here when we're done. So first of all, x times 3x squared gives us 3x cubed. X times 1 gives us plus x. 1 times 3x squared gives us 3x squared. And then 1 times 1 gives us plus 1. On our denominator, again, you want to be very careful. When you have a bunch of terms being added or subtracted together within parentheses like this, and it's all squared, the squared does not just simply distribute into these terms. What we need to do is write out x cubed plus x minus 2 times x cubed plus x minus 2. Because remember, something squared just means that thing times itself. We need to times this whole thing by itself. So then we can go ahead and We would be able to combine our like terms within these parentheses here at this point. In this case, there are no like terms. So we can just go ahead and distribute the negative sign to all 4 of these terms now. So we're going to get x cubed plus x minus 2 from out here, minus 3x cubed, minus x, minus 3x squared, minus 1. And then on our denominator, this gets a little bit kind of complicated to keep track of. We're going to do basically the first term times each of these 3, then the second term times each of these 3, then the third term times each of these 3. So I'm going to go ahead and do kind of multiple colors here so we can keep track of this. So first we're going to do this first term here times each of these 3 terms. So x cubed times x cubed gives us, when you multiply 2 things with the same base, you add the power. So that gives us x to the 6th. X cubed times x gives us plus x to the 4th. And then x cubed times negative 2 gives us minus 2x cubed. Okay. Then we're going to go ahead and do this second term plus x times each of these 3. So x times x cubed gives us plus x to the 4th. X cubed times x is plus x squared. X times negative 2 is minus 2x. And then we'll have the minus 2 now being multiplied by each of these 3 terms. So minus 2 times x cubed is minus 2x cubed. Minus 2 times x is minus 2x. And minus 2 times minus 2 is plus 4. Let's go ahead and we will combine our like terms on the numerator. So we have an x cubed and a minus 3x cubed here. So that gives us minus 2x cubed. We have a minus 3x squared. Then we have a plus x and a minus x. So those are going to cancel. And then we have a minus 2 and a minus 1. So that gives us minus 3. So the x cubed, minus 3x cubed, counted for those. The minus 2, the minus 1, and the minus 3x squared. Okay, so I accounted for all those down here. Okay, so then again, we can combine our like terms on the denominator at this point. So there's only one x to the 6th here. Then we have x to the 4th. So that's accounted for. X to the 4th plus x to the 4th gives us plus 2 x to the 4th. Minus 2x cubed minus 2x cubed. So that's minus 4x cubed. Plus x squared, and that's the only x squared term. Minus 2x gives us minus 4x, and plus 4. It's quite a doozy. And then, yeah, there's no more like terms, no more distributing. There's no really anything else to do there. So that should be it for that. Well, I hope you found this video helpful. If you did, please be sure to hit that like button down below and that subscribe button too with the bell icon while you're down there. And like I said, this was covered on my Calculus 1 study guide and my complete Calculus 1 package. You can click on the links down in the description below for more info on those. But if you want to keep learning about quotient rule or other topics on derivatives, just go ahead and click on one of those videos over there and keep on learning. Thanks, and see you next time.